Suppose we have the function y equals g multiplied by h. This function can be visualized as the area of the rectangle with sides of length g and h. As the variable x changes, the area of the rectangle also changes. Suppose we increase x by just a very tiny amount, which we will call dx. This will cause g to change by a tiny amount, which we will call dg. This will also cause h to change by a tiny amount, which we will call dh. As x increases by the amount dx, the area of the rectangle will increase by approximately the area of these two green rectangles. The area of this green rectangle is dg multiplied by h. The area of this other green rectangle is dh multiplied by g. The sum of these two areas is therefore dg multiplied by h plus dh multiplied by g. This sum is the amount by which y changes, which we will call dy. Therefore, if y equals g multiplied by h, then when we increase x by dx, the amount by which y increases, which we call dy, is equal to dg multiplied by h plus dh multiplied by g. dy divided by dx is what we call the derivative of y with respect to x, which we refer to as y prime. dg divided by dx is what we call the derivative of g with respect to x, which we refer to as g prime. dh divided by dx is what we call the derivative of h with respect to x, which we refer to as h prime. Therefore, if we divide both sides of this equation by dx, we get the following. Y prime is equal to g prime multiplied by h, plus h prime multiplied by g. Therefore, if y equals g multiplied by h, then the derivative of y, which we call y prime, is equal to g prime multiplied by h plus h prime multiplied by g. One last point. The increase in area of the square here is not exactly equal to the area of the green rectangles, due to the fact that we did not take into account the area of this red rectangle. However, the area of this red rectangle is dg multiplied by dh. dg and dh are very small numbers. Two small numbers multiplied by each other is an even smaller number. As the value for dx approaches 0, both dg and dh also approach 0, and the area of the red rectangle becomes negligible.